Now let's do another small two-sample averages problem. A student feels that her grades got better from her third to her fourth years. She is now in the middle of her fourth year. Not knowing any other way, she wishes to compare average grades in both years. The data is summarized as follows. In the third year, when she did 7 classes, the average grade was 3.42 with a standard deviation of 0.61. Well, in the fourth year, out of 4 classes, the average is 4.05 with a standard deviation of 0.56. Is there enough statistical information to conclude that her grades are improving? Use an alpha of 5%. Alright, I'm going to write down the sample information. So, sample 1, group 1, the first information that was given to us is the data from the third year. She did 7 classes, so N1 is 7. Average GPA there for those 7, 3.42, and S1 standard deviation of 0.61. And the fourth year, which we'll call group 2, she's done so far 4 classes, so N2 is 4. Average there is 4.05 in the sample. Grades are improving. And the standard deviation in the fourth year is 0.56. So the question asks, are the grades improving? Alright, which is a one-tailed test. It's a change in a particular direction. Either the grades got better or they got worse. We want to know if they got better. And we're going to do this question with an alpha 5%. So it's a one-tailed test, and as with all one-tailed tests on the Z and T, we have to now find out which tail we're going to use. And as we do with two-sample tests, we compare the two sample values. In this case, the X bar of 3.42 is clearly less than the X bar 2 of 4.05, so less than, points downwards. It's a lower tail test. In other words, our T or Z value is going to be negative, and we want a negative critical value to compare that to. So a lower tail test, and the alternate will be the population equivalent of this. So instead of X bar 1 being less than X bar 2, the population equivalent will be mu1 less than mu2. Remember that in the sample we have that the grades are improving, so the alternates will be where the grades are improving. Okay, so let's now write down both hypotheses. Alternate, as we have here, mu1 less than mu2, grades are improving. And the null, the complement of that, mu1 greater than or equal to mu2, grades are not improving. Averages problem, the next step, degrees of freedom. N1 plus N2 minus 2, that's 7 plus 4 minus 2 equals 9, which is less than 30, so we're going to use the T with 9 and do the small sample test. So at this point we draw our diagram. This will represent the T with 9 degrees of freedom. Middle of any T distribution is 0. This case is a lower tail test with an alpha of 5%. So we're going to go to our tables, look for a T with 9 and 5% in the one tail. assign degrees of freedom alpha of 5% in the one tail. Critical value is 1.833. Alright, so we have a lower tail test, so our critical value that we're going to use is a negative 1.833. Right? Negative number is less than 0, positive number is only greater than 0. And our decision rule will work as follows. If t-calc is greater than the negative 1.833, we get the acceptance region. It's possible the grades are not improving. If we get a t-calc less than the negative 1.833, it is likely the grades are improving. Okay, so let's write that down so there's no question about what was said. Decision rule. If t-calc is greater than or equal to the negative 1.833, null is possible. Do not reject the null. It is possible the grades are not improving. Alternatively, get in the rejection region where the alpha is. If t-calc is less than the negative 1.833, then two sample values are too far apart for the null to be likely. We'll reject the null and accept the alternate. And the interpretation, it is likely the grades are improving. Now we're ready to do our calculations. Let's do our calculations on a different page. Alright, first thing we need to do is sigma hat, combined sample standard deviation. Take the square root of all this, but we'll do the square root sign a little later. N1 minus 1 times S1 squared plus N2 minus 1 times S2 squared divided by the degrees of freedom, N1 plus N2 minus 2. Alright, and the square root of the whole thing. Alright, so N1 is 7, so 7 minus 1 times standard deviation of 0.61 squared plus N2 of 4 minus 1 times standard deviation S2 of 0.56 squared divided by the total degrees of freedom, 7 plus 4 minus 2, and square root of the whole thing. And let's go to Excel quickly and work that out. So it's equal square root of 7 minus 1 times 0.61 squared plus 4 minus 1 times 0.56 squared. 0.56 squared divided by degrees of freedom, 7 plus 4 minus 2, and the standard deviation sigma hat is 0.5938. Okay, and we make sure that the result is between the two sample values, in this case S1 of 0.61 and the S2 of 0.56. It is between, so we're not obviously wrong with that answer. Next step is the standard deviation S sub x bar 1 minus x bar 2, which is sigma hat times the square root of 1 over n1 plus 1 over n2. So the 0.5938 times the square root of 1 over 7 plus 1 over 4. And let's go back to Excel and work that out. So this is the square root of, so this is sigma hat, this number, times the square root of 1 over 7 plus 1 over 4, and the S of x bar 1 minus x bar 2 is 0.3722. And now we're finally ready for the T-calc, which is the sample difference, x bar 1 minus x bar 2, minus the hypothesized difference, mu1 minus mu2, divided by the standard deviation, S of x bar 1 minus x bar 2. Okay, the sample difference, x bar 1, 3.42, third year grades, minus x bar 2 of 4.05, hypothesized difference of 0 always, divided by the standard deviation, S of x bar 1 minus x bar 2, the 0.3722. And going back to Excel to work that out, it equals 3.42 minus 4.05 divided by standard deviation, and that's negative 1.693. Negative 1.693. Alright, and let's go back to our decision rule to see where that falls. Negative 1.693 is above the critical value, and we're faced that we're inside the acceptance region. So the decision is not to reject the null, and it seems like the grades are not improving. Alright, since T-calc is equal to the negative 1.693, which is greater than the negative 1.833, do not reject the null. These two sample averages are too close together to be able to tell what's happening, so it is possible the grades are not improving. And that's the end of that problem.